Okay, so now that we've done a lot of area, we can do more irregular figures. They are called composite figures. So we have to break these figures up into the different shapes that we know. We will also need our area formula reference sheet today. The one we've been using, although circle has been added, so we'll be working with circles also now that we know those. So in the first example, this is not a shape I recognize, but we can break it up into two different shapes. I have two options here. I could draw a horizontal line here and have a rectangle with a rectangle, or a vertical line here with, again, a rectangle and a rectangle. It doesn't matter which one you do. I'm just going to do this one. So the two shapes we have, and I like to write this out, are a rectangle and another rectangle. And after we find their individual areas, we're going to add them to find the total area of the figure. So I need to go to my area formula sheet and look up the formula. If I don't know it, area for a rectangle is length times width. I'll put that on both of them. All right, I'm going to start with the big rectangle first. Okay, so make sure you are finding whole sides, not parts of sides. So one whole side of this rectangle is 10, and another whole side is 6. So I'm going to be using 10 and 6. Notice 7 is only part of that side, and 11 goes past that rectangle. So 10 and 6 are my length and my width. And 10 times 6 is 60. All right, the other rectangle is trickier. Notice I don't see a number here, or here, or here, or here. So I'm gonna have to subtract to find some dimensions. So let's start with like this side. This side is part of the 11, but 11 is too big. So I'm going to look for another dimension that is also going horizontal, which is the 6 down here. So if this whole thing's 11 and this part is 6, that leaves 5 to be that dimension. Because 11 minus 6 is 5. We're going to do the same thing to find this vertical dimension. So now I'm looking at the vertical dimensions. I have 10, which is too big. Another vertical dimension, 7. But if I do 10, take away 7, that means there's 3 left for that little piece. So for the other rectangle, we are doing 5 times 3. And we get 15. And then lastly, to find the area of the entire figure, we're just going to add up our two answers and get 75 square feet. All right, next example here. This time I see a rectangle and a triangle. I don't have to make any lines myself. I'm just going to write those out. Again, I'll be adding those two areas together at the end. I go to my reference sheet to get my formulas. Area for a rectangle is still length times width. Area of a triangle, that's that 1/2 base times height. All right, let's go to our rectangle. Here's our rectangle over here. Here's my length of 21 and my width of 16. That's nice and easy to pick out. 21 times 16 gives us 336. And that takes care of the rectangle. Triangle's a little bit trickier because the triangle's on its side. We have to bring down that 1/2. So look at this triangle. The base is actually over here. It's kind of like turned on you. And I don't actually see that dimension. But because this is a rectangle, I know that that side must be equal to this side. So the base must be 21. And then the height of my triangle, how tall it is 12. Remember, it's always got to be a straight dimension. It can't be something slanted like the 13 or the 20. We actually don't even need those two dimensions. They're just extra. So the triangle, I don't want to do half of 21, but I like half of 12, which is 6. Bring down the times 21. And 6 times 21 is 126. Last step is to add them. And we get 462 square inches. All right. Next example here, I have to draw my own lines in. I'm going to draw one right here. Now I can see a triangle up top and a parallelogram on the bottom. So triangle formula, we have that from the last problem, is 1/2 base times height. Parallelogram formula off that reference sheet is base times height. All right, let's start with our triangle. Bring down the 1/2. Here's the base of my triangle. Ugh, I don't see that dimension again, but because that's a parallelogram, opposite sides are the same. So if that's 8, so is that. And the height of my triangle, I see it's 3. Notice it's not 7, that's too tall. That goes past the triangle. Half of 8 is 4. Bring down the times 3. And 4 times 3 is 12. That takes care of our triangle. On to our parallelogram. Base is nice and easy to pick out. There's the 8. The height, though, is trickier. I don't see this straight up and down dimension. So I have to look for other dimensions that are also going vertical. I see this long 7, that's too big, and I see the 3, that's part of the triangle. But if that whole thing is 7 and this piece is 3, that means my height must be 4, because 7 minus 3 is 4. And then 8 times 4 is 32. We'll add our two areas together. And we get 44 square centimeters. All right, on to the back. Again, I'm going to draw in some lines. This is not a shape I recognize. It kind of looks like a trapezoid, but there's too many sides. 1, 2, 3, 4, 5 sides. That's not a trapezoid. So I'm going to draw one in here. Now I do see a trapezoid up top. And on the bottom here, I see a rectangle. Gonna go grab those area formulas. For trapezoid, it's that long one, 1/2. Height, base 1 plus base 2. And the rectangle is length times width. All right, let's start with the trapezoid here. Bring down that 1/2. How tall my trapezoid is just this little piece. Ugh, I don't see it again. But if this whole thing is 15, and this piece is 13, 15 minus 13 means that little height must be 2. My two bases are the top and the bottom of that trapezoid. I can see the first base is 11. The other base is right here, which I don't see, but because I have a rectangle, I know these opposite sides are the same, so that it's also 16. Half of 2 is 1, and 11 plus 16 is 27, and 1 times 27 is 27. All right, that was the harder one. Onto our rectangle. The length of our rectangle is 16. Careful on the width. I see a 15 and a 13, but you want to pick the one that stops at that line there, which is the 13. The 15's too big. And then 16 times 13 is 208. And we will add our answers together. So we get 235 square inches. All right, getting into some even harder stuff. We're gonna start seeing some circular regions. Remember, that was what we did the other day, and we have pi in there. It gets a little tricky. Be careful with the circular ones and what they want. Like this problem wants your answer with a pi in it, while the next one we do is gonna want it to the nearest tenth. So just be careful about your final answer. All right, shape size C. I definitely see a nice little rectangle on the bottom here. And then up top, I don't see a whole circle, I see half a circle. I'm even gonna write that 1/2 in for myself so I don't forget to take half. Okay? All right, formulas. Area is length times width. Now for my circle, when I go to that reference sheet, it says pi r squared, but because I'm taking half, I'm gonna stick a half out in front and then write the pi r squared. All right, let's go back to our rectangle. It's the simplest one here. The two dimensions are given to us. That's 18 and 12. And 18 times 12 is 216. All right, onto our circle. I know I need to take half, so I'll keep that half there. Pi is just a symbol for a special number. That pi comes down. Now, the tricky part, finding the radius. So if I look at my circle, the radius is from the center to an edge. So just that piece right there. I don't see a dimension there, but because down here is a rectangle, I know the opposite side is the same measurement, so I know it's also 12. That means that 12 is the diameter of my circle, and we learned the other day that a radius is half of its diameter, which makes that radius 6. And don't forget the squared on it. So I'm going to keep my 1/2. I'm going to keep my pi. 6 times 6 is 36. I don't want to do half a pi, but half of 36 is 18. Keep my pi. All right, now we're gonna add 216 plus 18 pi. Remember, they want the answer in terms of pi, which means they want a pi in the answer. We're actually gonna leave our answer just like this. I'm gonna throw the units on real quick. Because I cannot add 216 with 18 pi because the 216 doesn't have a pi on it. They're not like terms. So it just gets left just like that. If they both had a pi, then you could totally add them. All right, last example together here. We have, I see 3 shapes this time. So on the top, I see a triangle. In the middle, I see a rectangle. And on the bottom, there's that curve representing like a part of a circle. I actually see a quarter circle. So again, I'm going to write that. I have a fourth of a circle. All right, I'm going to go grab all of our area formulas. 1/2 base times height, length times width. For a circle, I'm going to put the 1/4 out first and then write the circle formula, which is pi r squared. All right, now we got to substitute here. 1/2. Base. Base is the bottom of my triangle. I don't see that dimension, but if I have a rectangle here, I know that they are the same, so that's a 3. How tall my triangle is that vertical dimension, never a slanted one, so it's 4. So we just don't even need that 5 at all. I don't want to do half of 3, but half of 4 is 2. And 2 times 3 is 6. On to our rectangle. The 2 dimensions, nice and easy to see, are 3 and 11. They take up all the sides. And 3 times 11 is 33. On to our circle. Keep our 1/4. Keep our pi. All right, tricky part, finding our radius. So if you're looking at this quarter circle, you got to think about, remember, we need to go to the center. The center is actually right here. All the way to the edge. Oh, it's actually given to us. It's 3. We don't have a diameter this time that we have to take half of. So 1/4 pi times 9. And that's not very pretty. A fourth of 9, if I do 9 divided by 4, we get 2.25 pi. All right, we're going to add all these together. 6 plus 33 plus 2.25 pi. I'm going to combine the like terms. Only these two are alike because they don't have pi's on them. 6 plus 33 is 39. Now, if it had said in terms of pi, that would be my final answer, but it doesn't. It says the nearest 10, so they want you to type that in with the pi and get the final answer. So nearest 10th is going to come out to be 46.1, and let's make sure we put units on there. And that's it. You have another worksheet to do on your own to practice this. Make sure you're using that area formulas reference sheet. That's it.